As part 2 of our look at factorizing, we're going to look at factorizing a quadratic. Now, previously we learned that we could expand and multiply out the products of two brackets. So, for example, if we took x plus 1 and multiplied it by x plus 3, we could expand these out and then simplify. So we take the first term in the first bracket and multiply it by the first term in the second bracket to get x squared. Then we take the first term in the first bracket, multiply it by the second term in the second bracket to get 3x. And likewise, we'll take the second term now in the first bracket, multiply it by the first term in the second bracket, and we'll get 1 times x is x. And last, we'll take the second term in the first bracket and multiply it by the second term in the second bracket. So 1 times 3 will give me 3. So we just simply called that expansion, or multiplying out of the brackets. The next thing to do was to try and simplify this by gathering like terms. So we can see here the 3x and the 1x are like terms, so we're going to get x squared. 3x plus 1x is going to give us 4x, and then we get the remaining 3, and this is called simplification. Now, what we're going to be doing in factorizing is to do the reverse process. We're going to try and take an expression like this one, x squared plus 4x plus 3, which is a quadratic, and turn it back into a pair of brackets like that. In other words, each of these terms, x plus 1 and x plus 3, are factors of x squared plus 4x plus 3. So let's take this expression x squared plus 7x plus 6. Now, as we've already hinted, we're going to end up with two factors, more likely, with two brackets required. To start with, we're going to assume that the coefficient in front of the x squared is going to be 1. We'll get cases later on where that will not be true, but for now we're going to assume that the coefficient in front of x squared is 1. This will mean that we can start off by filling in our brackets with an x and an x, because an x times an x will give me an x squared. The question is, what goes in here, what goes in here, and do we use a plus or a minus in here to get the result? So we'll start off by looking or investigating with this number here, 6. We want to know what numbers put in here and here multiplied together can give me 6. In other words, I'm asking what are the factors of 6. Well, we can put those down straight away. We can have 1 times 6 is 6, and we can have 2 times 3 equals 6. Now, it's not trivial to say that we should also consider 6 times 1 equals 6 and 3 times 2 equals 6. In other words, I've taken the reverse of 1 times 6, made it 6 times 1, and likewise 2 times 3 reversed that to 3 times 2. So these numbers here, these combinations to give me 6, means that I could have 1 times 6 in there, or 6 times 1, 2 times 3, or 3 times 2. To decide which it is, I need to look at the second number here, the one in front of the x. So I need to generate a number 7 using the numbers 1 and 6, or 2 and 3. So I'm going to try and look at those pairs to see how I can do that. So I could, for example, have 1 plus 6 would give me a 7, or 6 plus 1 would give me a 7. Or I could have 6 take away 1, give me a 5, or 1 take away a 6 to give me a minus 5. That's pretty well all I can do with 1 and 6. Alright, let's do the same with the 2 and 3. I've got 2 plus 3 will give me 5. I've got 3 plus 2 will give me 5. 3 minus 2 will give me 1. And 2 minus 3 will give me minus 1. I think we can see here that the only combinations that will give me 7 are these two up here. All these others do not support what I'm trying to do. The only combinations therefore I can use are these two here. And it doesn't really matter whether I use a 1 and a 6 in this case, or a 6 and a 1. So I'm going to put a 1 in there and a 6 in there. And because I'm trying to add them up, I'm going to end up with a +1 there and a +6 there. I need to get a +1 and a +6. So there's my solution. Now my solution can equally be x plus 6 and x plus 1, but that's being slightly pedantic, I think. Let's try another example then. We have here x squared minus 7x plus 12. So we're going to assume again we're going to need a couple of brackets. So let's put down our two brackets. There's a 1 in front of the x squared, so we're going to assume again x times x will give us x squared. So we'll start again by looking at this number here, 12, and ask ourselves what factors multiply together will give us 12. So we've got, for example, 1 times 12 equals 12. We could have 2 times 6 equals 12. 3 times 4 equals 12. Now again, we could have the other cases. If we reverse the numbers, 12 times 1 equals 12, 6 times 2 equals 12, and 4 times 3 equals 12. They're not trivial. We should really consider those too, even though all we've done is reverse the numbers. Now the question is, what combinations of these numbers 1 and 12, 2 and 6 and 3 and 4 can be made up to give us what we want secondly, which is a minus 7. So let's look at all the various combinations we can have. We can have 1 plus 12, and that will give us 13. I think we'll strike out on that. We could have 1 minus 12, and that will give us minus 11. We'll strike out on that. And then we can have 12 minus 1, and that will give us 11. And again, that's a strikeout. What about the 3 and the 4? Well, the 3 plus 4 will give us a 7. Now that's actually a strikeout because we want a minus 7. We could have a 3 take away 4, and that'll give us a minus 1. Strike out on that. 4 minus 3, which will give us 1. That's a strikeout. Then we could have a minus 3 and a minus 4, which would give us a minus 7. Now, we still ought to consider the other example, 2 and 6, just to be sure, but that looks like a solid answer for us there. Let's take the 2 and the 6. 2 plus 6 will give us 8. Obviously 6 plus 2 will give us 8 as well. But 6 take away 2 will give us 4, and 2 take away 6 will give us minus 4. All these will strike out. So the only thing we can work on is this one here. So it looks like we're going to have a 3 there and a 4 there. 3 times 4 will give us the 12, but we need a negative 7. So we need a negative 3 and a negative 4, and fortunately a negative times a negative times a negative will give us a plus. So our solution is x minus 3 multiplied by x minus 4. In other words, x minus 3 is one factor and x minus 4 is the other. Let's have a look then at exercise 4.6, and we'll have a look at answering question 1, x squared plus 8x plus 7. So let's put down then the two brackets we're going to need to solve this expression to factorize it. We'll put in x and x to get our x squared. We multiply those together. Now we need to look at this 7 and ask ourselves, what are the factors of 7? Well, this is fairly easy. 1 times 7 gives me 7, or of course 7 times 1 gives me 7. There's no other factors of 7 because 7 of course is a prime number. Now, what combinations can I use with 1 and 7 to give me the number 8? Well, this one is pretty much straightforward. We've got 1 plus 7 will give me 8. Or of course, reversing that, 7 plus 1 will give me 8. So it looks like I'm going to put a 1 in there and a 7, or I could make it the other way around, and then a plus here and a plus here. So the 1 times 7 will give me the 7. 1x plus 7x over here will give me the 8. So this looks like my solution. X plus 1 is one factor, and x plus 7 is the other. Let's increase the challenge a little bit by looking at question number 3. That says x squared plus 5x plus 6. We've got to factorize that. So we'll start our solution as normally we do with 2 brackets. And we're going to put an x in here and an x in here. And the first thing we're going to do is consider the 6. We need to know what factors we have for 6. Well, 1 times 6 will give me 6. Obviously 6 times 1 will give me 6. But 2 times 3 will also give me 6. And 3 times 2 will give me 6. So these are my obvious candidates. Now I need to be able to use the pairs, that's the 1 and the 6, and the 2 and the 3, to see if I can come up with a combination in adding or subtracting to give me the 5 in the middle here, 5x. So let's try that then. We have 1 plus 6 will equal 7, but of course 6 plus 1 equals 7. That does not equal 5, so these fail. I could have 6 take away 1 to give me 5. Now that seems to meet the 5, but I'm going to end up with a negative 1 and a plus 6. In other words, a plus 6 there and a minus 1 here. Now the problem with that is I'll have a multiplication of a plus and a minus. And a plus and a minus multiplied together will not give me the plus I want here, they'll give me a negative. So I don't think that combination is going to work either. Let's go back and try 1 take away 6 will give me a minus 5. Well, that's no good, I need a plus 5, so that doesn't work. So let's try the 2's and the 3's now. 2 plus 3 equals 5. I think we've done it. We got a plus 2 and a plus 3 will give me a 5. So a 2 goes in here, a 3 goes in here, a plus 2, a plus 3. 2 times 3 will give me 6. 2x plus 3x will give me the 5x. This looks like my solution. And let's up the challenge one more time. We'll try question 17, which says x squared plus 12x plus 32. We need to find the factors of that. So again, put our brackets down. And look at the last number here, 32, and look for factors of 32. I guess 1 times 32 will give us 32. 2 times 16 will give us 32. And maybe 4 times 8 will give us 32. Now we can always reverse those numbers as well. But we'll now just consider how we can use these numbers in combination to give us the number 12 here, the middle number. Well, it wouldn't take much investigation to realize that we were not going to be able to do it 1 and 32 or with 2 and 16. But 4 plus 8 will give us 12. So it looks like it's going to be x in here and x with a plus 4 and a plus 8. 4 times 8 is 32, and then 4x plus 8x will give me the 12x. So this looks like our solution. They're all very similar, so why don't you have a go at some more of these problems and see if you can challenge yourself.